Okay, a brother and a sister always went home from school together at the same speed. So they walked together. One day, 15 minutes after they left school, the sister forgot her lunch bag at school entrance. The brother ran back to pick up the lunch bag. The sister continued to walk home while the brother was getting the lunch bag, but twice as slow of her normal speed. After the brother caught up with the sister, the sibling went at their regular speed but arrived home 6 minutes later than usual. How many times faster did the brother run when he went back to school to get the lunch bag? Okay. First of all, we have to identify what they did not tell us. Okay, so they actually didn't tell us. The first thing they didn't tell us is what is the actual speed they walk from school to home. So let's let x be the normal speed, and this applies to both the brother and the sister. Okay, so one day, 15 minutes after, the sister forgot her lunch bag. Okay, so to draw a certain picture here, so for 15 minutes, they walked, and then the sister, she walked at the speed of x. Okay, we let x be the normal speed. And then she walked a certain amount at half the speed. And then she walked at normal speed again. Let this time be t. We don't know what the time is. If that's t1, and let me call this t2. Okay. All right, and actually we don't actually know what the actual time, the normal speed, how long it takes for them to get home when they walk normal speed. So this time I'm gonna call it t. Okay, in other words, 15 plus t1 plus t2, right? So t is equal to 15 plus t1 plus t2. Okay. Now there's two separate motions here, right? The motions of the sister and the motions of the brother. At the end of the day, right, they arrive home at the same time. This is the key to solving this problem. I'm gonna first write an algebraic expression of how long the sister took. Okay, so initially, for the sister, okay, so I'm gonna do this for the sister, and then I'm gonna get an algebraic expression for the brother, and when we make them equal to each other, we're gonna get an equation which will lead to the answer. So for the sister, initially, she walked 15 minutes. Okay. And okay, so actually, sorry, 15 minutes at the speed of x. Okay, that's describing this first part. The second part here will be x over 2 times by t1. Okay, and this last part will be back to speed of x, and time is t2. So this equals, to what if she were to walk normally, which would be covering the distance by speed times by time, but she takes 6 minutes more, so plus 6. Okay, now because we have this relationship with the t1 and t2 and t, right, we can actually make t2 in terms of t1 and t. Now before I do that though, what is a common variable in all of these terms? Hopefully you can see it. It's x, 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 x. So we can actually divide both sides by x and get this. And this right here can be replaced with t minus 15 minus t1. Let's continue to simplify this. Both sides has t. The 15 also cancels out, and we get t1 over 2 is equal to 6. And something very nice happens. T1 is 12 minutes. So we just found out that this right here is 12 minutes. Okay. And the difficult part really is this setup here, right? Writing a distance of how the sister walked through this entire thing. Okay. I know the brother is doing something. He's going back to go get the lunchbox, but this is what happens to the sister. And with that alone, we were able to find out that it's been 12 minutes. Okay, so up to here will be the hint, right? See if you can use that time to figure out setup so that we can find how many times faster the brother actually ran. Okay, so now let's visualize the brother's movement. Okay, starts, goes for 15 minutes, and then realizes that we have to get the lunchbox, so it goes back, comes around, and goes straight home. Okay, so let's do his distance. Okay, so this distance right there, okay, that right there is still just 15 minutes at the speed of x. Now this right here, right, so he went back, came back, and met with the sister. This is 12 minutes exactly. Okay, so it's 12 minutes, but he didn't go at x. He went at some multiple of x. How many times faster? So I'm going to let I'm going to introduce k to indicate k times some x, the normal speed of x. Okay, and then lastly, right, to t2. Remember t2 here we can express as t minus 15 minus t1. So t minus 15 minus t1. That we traveled again at the speed of x. Okay, and this was still, of course, he arrived at the exact same time as his sister. So x times t, right, same setup is here, plus 6. Okay. Again, exactly the same. Let's get rid of all the x's. Okay. And we actually know this right here as well. So we get 15 plus 12k plus t minus 15 minus 12, that's minus 27, is equal to t plus 6. This goes away. We have 12k, 15 minus 27. Okay, 15 minus 27, that's minus 12. So you get 12k is equal to 18. Divide both sides by 6, you get 2k is equal to 3. So k is 3 over 2. Okay, that's the multiple. This is 1.5 times. So therefore, the brother ran 1.5 times faster, or walked 1.5 times faster than the normal walking speed.